All right, let's dive right in. We are going deep inside the human brain. I mean, the most complex thing we know of in the entire universe, to really try and understand what goes wrong, what goes haywire during psychosis. This is going to be a journey right into the brain's most intricate circuitry.
Okay, so first things first. It is so important to get this one thing straight. Psychosis is not a single illness. Think of it more as a syndrome, just a collection of symptoms. You know, it's kind of like a fever. A fever tells you something's wrong for sure, but it doesn't tell you if it's the flu or something else. Well, psychosis is a lot like that. It's a major sign that there's a deeper issue, and it can show up in a whole bunch of different conditions.
At the absolute heart of this syndrome, you'll find two core experiences. On one side, you've got delusions. These are deeply held, totally fixed beliefs that just don't change, even when you're shown evidence to the contrary. And on the other side, you have hallucinations, really vivid sensory experiences like hearing voices that feel completely real, but there's nothing there causing them. You have to have at least one of these to be experiencing psychosis.
Now, here's where it gets interesting. We sort these symptoms into two big buckets, and this gives us a huge clue for our investigation. Positive symptoms are the ones that add an experience, so the delusions and hallucinations we were just talking about. They're positive in a mathematical sense, like adding something to the equation. Then you have negative symptoms, which are all about things being taken away. This is stuff like a withdrawal from the world, apathy, no motivation, or just a real flattening of emotions.
For decades, if you were investigating psychosis, you had one prime suspect, a little neurotransmitter you've probably heard of called dopamine. The classic theory, the dopamine hypothesis, tells this really elegant story of too much in one part of the brain and too little in another.
So here's the too much part of the story. The theory says that in the brain's reward and motivation circuit, it's called the mesolimbic pathway, there's just a flood of dopamine, way too much activity. And this hyperactivity is thought to be the thing that directly causes those positive symptoms we talked about, the delusions and the hallucinations.
But at the exact same time, in a completely different part of the brain, you have the total opposite problem. In the mesocortical pathway, which is critical for thinking and managing emotions, there is not enough dopamine. And this shortage, this deficiency, is what we think causes those really tough negative symptoms, like the apathy and the emotional withdrawal.
So the picture seems pretty clear, doesn't it? You've got one chemical, dopamine, that's simultaneously cranked up way too high in one circuit and turned down way too low in another. It just neatly explains both positive and negative symptoms. But this beautiful, simple explanation actually leads us to a much, much deeper question.
I mean, if dopamine is the problem, what's knocking it out of whack in the first place? What's the real root cause here? It turns out, dopamine might not be the real culprit after all. It might be more like the getaway driver in a much bigger heist.
And this is where the story takes a really fascinating plot twist. The investigation leads us upstream to a totally different key player, a neurotransmitter called glutamate. Glutamate is the brain's main go signal, its main excitatory chemical. People often call it the master switch because it can basically turn on any neuron it touches.
This idea just completely reframes the entire problem. What this new hypothesis suggests is that the dopamine imbalance isn't the cause of psychosis at all. No, it's the downstream effect. It's the consequence of a primary failure way up the chain in the glutamate system.
So the new theory points its finger at something called NMDA receptor hypofunction. Look, in simple terms, it just means a specific type of landing pad for glutamate, the NMDA receptor, is broken, and it's failing on these incredibly important neurons, we call them GABA interneurons, whose entire job is to act like the brakes for the brain and keep other neurons from just firing out of control.
And when this one little thing fails, it sets off this massive chain reaction. First, that broken NMDA receptor on the GABA brake neuron doesn't get its signal, so the GABA neuron doesn't fire. The brakes are off. What happens next? Well, the next glutamate neuron in the chain is now disinhibited. It's basically free to just fire like crazy, becoming totally hyperactive. And it's that runaway glutamate activity that ultimately creates the dopamine chaos we see way downstream.
So what this all points to is this huge shift in our understanding. Psychosis isn't just some simple chemical imbalance. It's a much more complex, much more profound problem with the brain's fundamental wiring. It's a circuit problem. And the evidence shows it's not even just these two. Other systems, like serotonin, are also deeply involved in managing this incredibly delicate network. So yeah, dopamine is the thing you see at the end, the downstream effect. But glutamate is the upstream driver causing the whole mess. and serotonin is a key regulator trying to keep it all in check. It's a real team effort.
But this isn't just some abstract theory in a textbook, right? This malfunctioning circuit, this electrical storm of hyperactivity inside the brain has real, tangible, physical consequences for the brain itself.
1%? What does that mean? Well, research has found that a single untreated first episode of psychosis can actually be neurotoxic. It can result in a loss of up to 1% of total brain volume. That is a measurable physical loss of brain tissue.
And this really highlights a critical fact. Time is brain. The longer an episode of psychosis is left untreated, the more structural damage can happen. It's a powerful, powerful argument for why getting help quickly, why early, decisive intervention isn't just a nice idea. It is absolutely essential to preserving the health of the brain.
This new understanding, as you can imagine, completely changes how we even think about treatment. We are moving away from this old, simple idea of just treating a chemical imbalance by blocking dopamine. Now we have to think about addressing a complex circuit problem. The goal isn't just to treat the effect anymore, it's to figure out how to address the cause, how to stabilize, or maybe even rewire the entire network. And that right there is the fundamental challenge. This is why it is so incredibly difficult to develop truly effective treatments. It's not about just tweaking a single chemical, dial up or down. It's about trying to bring this complex, interconnected, and malfunctioning electrical grid back into a stable balance. And so this new understanding leaves us with this provocative, but also really hopeful question for the future. By finally seeing psychosis for what it is, a circuit problem, we open up a whole new frontier for treatment. Can we start to develop therapies that don't just put a Band-Aid on the symptoms, but that can actually help the brain restore its own delicate, intricate balance? That is the challenge and the hope that lies ahead.